Okay, so in this video, we're going to look at how we can describe some of the data distribution, okay? And we're going to introduce these little guys called outliers and have a look at them. So to start off with, as we've seen in the past videos, we've seen these now before, right? We've seen something that looks like this, roughly. And I sort of showed you how we can put a curve over this. Okay, and we see that this curve has symmetry, okay, or that these bars have symmetry straight down there. And we call this a symmetrical distribution. So a symmetrical distribution is when we have symmetry amongst the line that we put over the top. So it's just a nice symmetrical curve like that. What happens though is, what if we get something that looks like this? Something like that. Well, what's happened is this tail over the right-hand side has been stretched out, and our curve that we sort of draw now looks something more like this. And when the tail has been pulled out in the positive direction, so up the x-axis to the right, we call this positively skewed. Okay? And a similar idea applies for if it was going the other way. So let's say we sort of climb up the hill towards the big valley and then it drops off rapidly. We've now got, if we put our curve over the top, it climbs and then it falls straight away. So we kind of got this climb and then an immediate collapse because the tail has been pulled in the negative direction. It's been pulled to the left, down the x-axis. So we call this negatively skewed. Okay, and finally, we've got this idea of something that we call bimodal. So let's say we've got this here. So remember, our mode is the one that occurs the most. So here, this is our mode. Here, this is symmetrical about our mode, which is here. So when I say symmetrical about the mode, the line of symmetry goes directly down our mode, right? Here, this is our mode. And here, well, we've got two modes. Okay, and this is symbolic by the two sort of humps that we've got. If we were to draw our lines over here, we kind of got these two humps. And whenever we get, oh, what's happened there? Whenever we get our two sort of humps, we call this bimodal. So there's some important terms to remember, okay? And you'll do some more problems with these in the worksheet that I've provided because it's no different to just plotting what you've done in the last two videos, and then now we've got to describe the data using one of these four words, okay? So that's it between symmetrical distribution, being positively skewed, negatively skewed, and bimodal distributions, okay? Now I want to have a look at outliers. And outliers are guys that look like they don't belong. So for example, let's take the following data set like this. Say number of jelly beans eaten at a birthday party. We did that one before. And let's say our data set looks like this. 3, 4, someone else ate 3, another person eating 2, and then someone ate 27 jelly beans. This guy here is a clear outlier, okay? And what we have to do with outliers is identify, do we keep them or do we ignore them? Now, the only way that we are allowed to ignore them is if we are sure that we've made an error or there is reason for error here. So for example, the kid lied. So the kid lied and said he ate 27 jelly beans and he wasn't telling the truth. Then we could ignore that outlier, okay? So we could remove it from our data set. However, if the kid did in fact actually eat 27 jelly beans, then we have to keep that point in our data set. Another example is if we take the height of people in a year 10 classroom. So you got someone at 154, 156, 157, 168, 169, 175, okay? And then you've got someone at 200 centimeters. We would say that this is the outlier. And we have to work out, is that person actually 200 centimeters? Which if they are, we have to keep them in the data set. But if we read the tape measure wrong, okay, then we can suggest that it could potentially be okay to remove this point from our data set. And what does this look like graphically? Well, let's take the following graph, and we've started to see plenty of these now. We've got this sort of collection in here. And then we got one all the way down there like that. We would identify this is an outlier. And once again, I can't emphasize this enough, we have to put it down to why does that outlier exist? Was it a potential error in our experiment, in our survey, in which case, yes, we could potentially exclude that point as long as we say why we're doing so. But if that point does in fact truthfully exist there, then we have to keep it in our data set, okay, and explain why that point is where it is. Okay, so that's it. That's all I wanted to talk about with symmetrical distribution, positively skewed, negatively skewed, bimodal, and outliers.